Hi everyone, in today's lesson we're going to solve equations with rational exponents. So the rule for solving equations with these types of exponents is that we have to raise both sides to the reciprocal power. So let's just show you what I mean by that. So if we have a as our exponent and we want to raise it to the 1 over a, what does that give us? Okay, well let's see. So a times 1 over a. So we know we can make any number a fraction by putting it over 1. And we know to multiply fractions, we multiply straight across. So a times 1 is a, and 1 times a is also a. So a divided by a, anything divided by itself, is in fact 1. So when we raise a power to another power, the rule for the exponent property is to multiply. So when we multiply them, we actually get 1. So it's x to the first power. Now, what if we did the other way around? What if we started with 1 over a and we raised it to the a power? So if we raise it to the a power, it's like, multiplying the powers. So 1 over a times a, again, we can put the a over 1. We multiply straight across. So 1 times a is a times 1 is also a. So anything divided by itself is 1 again. So this gives me x to the 1. So this is just a proof that when you raise a power, a, to its reciprocal, remember reciprocal means 1 over, we will get 1. So that's what we're going to do in the scenario like number 1. We have x to the 2/3. We want to isolate the x. So the only way we're going to be able to do that is to raise both sides to the reciprocal power. So 3 over 2 over here and 3 over 2. So let's write that. We're going to raise both sides to the 3 over 2 power, or the reciprocal. So when we would multiply, right, when I raise a power to a power, the rule is multiply. So you're multiplying 2/3 by 3/2. And when you multiply straight across, 2 times 3 is 6, and 3 times 2 is also 6. So 6 divided by 6 gives you 1. So when you raise both sides to the reciprocal power, the exponents cancel to 1. So we've got x to the first equals. Now this 25 to the 3/2 power, you're just going to type into your calculators. So you're going to type in 25 to the 3/2. Make sure you put the 3/2 in parentheses and make sure you hit to the. All right. So take a couple minutes, plug that into your calculator, and hit resume when you're ready. All right. So you should have gotten 125. So x to the first is the same thing as saying x. So x must equal 125. Now let's do a check just to make sure that we are correct. So we're going to plug into the original equation. So x to the 2/3 equals 25. So since my x value we got was 125, we're going to plug in 125 in for here. We're going to raise it to the 2/3 power, and we're going to see if we get 25. So take a couple minutes, plug this into your calculator just the way you see it. Parenthesis 125, close the parenthesis, and raise it to the 2/3 power, and see if you get 25. And then hit resume when you're ready. All right, you should definitely get 25. So 25 equals 25. We check this out. It works. So we get to keep that my answer is 125. If it doesn't check, then that would mean that you'd have to reject the answer. All right, let's take a look at example number 2. So before we can do example number 2, there is a special note. Whenever you are solving equations with rational exponents whose numerator is an even number, you will always have two solutions. So do not forget the plus or minus signs. So this is something that we're going to probably need in a couple of problems. So let's just try to see what we can do with number 2. So the first thing I notice is that I have a root and a power here. So in order to do number 2, we really have to remember the rule. So x to the power over root equals something root of x to the power. So in this scenario, we have 3 as my root, cube root of x to the 5th. So my root in this scenario is going to be 3, right? It's the cube root of x to the 5th. So 3 is my root, 5 is my power. So I'm going to go back and say this is x to the 5 over 3. So we're just going to rewrite that. So we have 2 times x to the 5 thirds plus 1 must equal 487. So in order to solve any equation like this, we have to try to isolate the x. So we're going to get this x to the 5 thirds by itself. So what we need to do first is subtract the 1. So we have 2x to the 5 thirds must equal 486. And then we still haven't isolated this yet. We have to divide the 2 out, right? It's attached by multiplication, so we're going to divide. So when we divide it, we get x to the 5 thirds equals 486 divided by 2. If you do that, you should get 243. So now that we've isolated the x, we can now raise to the reciprocal power. So the reciprocal power of 5 over 3 is 3 over 5. So whatever I do to one side, I have to do to the other. Now remember, when I have an exponent raised to another exponent, the rule is multiplication. So 5 thirds times 3 fifths, when you multiply them, 5 times 3 gives you 15, and 3 times 5 also gives you 15. So when you divide them, you'll get 1. So these cancel to 1. So we have x to the first equals whatever this comes out to. So take a couple seconds, throw this into your calculator just the way you see it. 243 in parentheses raised to the 3/5 power. Pause the video and then hit resume when you're ready for the answer. All right, so you should have gotten x is equal to 27. So x to the first is the same thing as saying x, right? So x is equal to 27. So we didn't actually need to use this note that I had up here about the even exponent because the numerator was 5. It was odd. So let's try another example where we'll have to use this special note. All right, so I think I'd like to try question number 6. So if you notice in question number 6, the exponent in the numerator is even. So what is going to happen is we're going to have 2 solutions. So you can write 2 solutions because numerator is even. And I'll explain as we go through what that means. So is my x isolated? Pretty much, it's the only thing that's left on this side, so I don't have to solve anything. So we're just going to now raise to the reciprocal power. So this gets a 3/2, and this gets a 3/2. Now, if we follow the same pattern, whenever we raise a power to its reciprocal, we know that it's going to just cancel out to 1. So we have x plus 2 to the first power must equal 4 to the 3/2. So we're going to take a minute and we're going to put 4 to the 3/2 in our calculator, and we're going to hit resume when we're ready for the answer. All right, so you should be getting 8. And now we can solve. So x plus 2 to the first is really x plus 2. And what we have to remember is that we're going to have 2 solutions. And the 2 solutions are going to be here. So it's actually going to be plus or minus 8 is the answer. And the reason why is because of this. So remember how we did root and power? So if we have 3 and 2, 2 would be my root, that's on the bottom, and 3 would be my power. So what would happen is if we were changing this, this would be a square root of 4 to the third. And we know that 4 to the third is 64. We also know the square root of 64 is 8. Why? Because 8 times 8 gives me 64. But the square root of 64 can also be negative 8. Why? Because negative 8 times negative 8 is also a positive 64. So whenever you have an even number in the numerator in the beginning of the problem, when you flip it, it's going to cause an even root, right? A 2 is at the bottom. So if it causes that even root on the bottom, then we're going to also have this plus or minus. So it's a little tricky as far as where to see it, but that is where it would go. And then what you're going to do is you're going to make two equations and solve. So you're going to have x plus 2 equals 8, and you're going to have x plus 2 equals negative 8. And then you're going to solve. So you're going to subtract 2 on both sides, and we have x is equal to 6. And we're going to subtract 2 on both sides, and we'll have x is equal to negative 10. So we will have two solutions here. Now, just for purposes of time, I'm not going to do the check. Reason being is because most of the time the checks will work out. There really is no need to reject any solutions often. So the answers you get are really the answers that it should be. The check is really there for you. If you're taking an exam and you want to make sure your answers are correct, that would be helpful there. Okay, so what I'd actually like you guys to do for a couple of homework problems is why don't you see if you can try example number uh, 4 and example number 5. We'll skip 3 for now, and then we can go over those in class tomorrow. All right, have a good night.